to episode 7 of the IT Fundamentals training series. I am your host, Mark Haupt. Today, we are going to talk about firmware, BIOS, post, and all those things that get things moving. Welcome to the IT Fundamentals training series. This is episode 7, and today we're going to talk about the BIOS and the firmware and other situations like that that actually get your computer moving. So our previous conversations have been really talking about hardware and CPUs and all the little components that make things happen. And now we're bringing it all together where we're actually putting the power on the case and on the computer, and we're actually going to start seeing things on the screen. So what we need to be looking at here, or what we are looking at here, is what's called firmware. And there's a series of things here that are happening that the book, I've read the book, and it doesn't really identify clearly that it's a series of things. But if you start drawing lines under the highlighting different aspects of the items that are in the book, you'll start seeing a sequence here. So first of all, let's talk about the things that they're spoken of in the book. So there is firmware. Now, the book does tell us, and I just want to reemphasize this, that firmware is actually a piece of software. Okay, so the reason we call it firmware is because it's a firm piece of hardware or software that's put onto a encoded, they call it, onto a piece of hardware. And what that means is that it's a pretty, when I say it's firm, that means it's pretty static. It doesn't change very often. You very rarely have security vulnerabilities in firmware. And part of the reason for that is because firmware doesn't do much except for connects the pieces of the computer together and starts them up and running. So really the vulnerabilities that you would have to use with firmware are things when you have the computer or the hardware itself, the piece of hardware right in front of you. So certainly there are vulnerabilities there that we need to address, but firmware is that encoded piece of software that's designed specifically for the hardware that it sits on. Now, if you look at figure 1.2, you're looking at what's called a BIOS chip here, and the BIOS is basic input output system. And that is a piece of firmware, again, software, but firmware that's specific for the motherboard that you have inside of your computer. And what that does is, if you look at figure 1.2, going back to some of the learning that we've done in the past, you'll see all these little silver legs, almost like a centipede going out of this chip. Well, the chip itself is where the firmware resides, and it's a piece of software that's on that memory chip, and that's what this is a memory chip. And all those silver legs going out of there are bus. That's the bus that's leading to the various components in different places on the motherboard here on the computer. So that's kind of a visualization of pretty much everything that we've talked about. You have a memory chip here. You have some processing that occurs. You have the bus legs, if you will, that are going outside of that chip, and it's right there in front of you. And you could tell that it's BIOS because it's got a little stamp on it, or perhaps a sticker that identifies it as the BIOS. Now, so we talked about this being a sequence. So your firmware is placed onto the physical hardware chip device. It's encoded on there, is what they call it. It is what they call read-only memory. So, we talked about RAM, which is random access memory, and that's a volatile type of memory. But now we want to talk about a more non-volatile type of memory. And because this is read-only, you can't change it very easily. That would be almost like a hard drive. This chip is here that we're dealing with is almost like a hard drive. It is a non-volatile piece of memory in essence. So it goes onto that chip. The firmware goes onto that chip. So if you're talking about sequence, you have the chip and that sits on the motherboard, and then you have the firmware that's encoded and placed on that. And specifically, we're talking about BIOS because in this case, we're talking about motherboard, although the firmware could be applied to an expansion card, a PCIe. Remember, we talked about that in the last episode, PCIe expansion card specifically for graphics or specifically for a network interface card or something like that. But you've got the BIOS. And then from there, you have that will execute what's called post on the motherboard, which is power on self test. So the power on self test is absolutely important for this process, because that is kind of the mathematical and other sequence that it goes through in order to get started. So what does post do? And I'm just going to read from the book a little bit here and expand on. So it verifies the integrity of the BIOS itself. So there's a function inside this BIOS that make sure that the BIOS is correct. It's encoded for that particular type of card or motherboard. And it also sometimes does a little bit of a security function. And then it verifies and confirms the size of the primary memory. So now it's reaching out to the RAM device and it's going, hey, do you match what I'm expecting here? Do you have 8 gig? Do you have 16 gig? Do you have 32, 64, 128? It's matching what has been placed into there before, or what it's detecting. Then it analyzes and catalogs other forms of hardware such as buses and boot devices. So really what it's doing is going out and it's kind of spray and like sprays out a message that says, okay, now everything that's attached to the motherboard, whether it's physically attached through the bus, or it's attached through a PCIe, or it's perhaps attached through an IDE or a SATA connector, it is now going out there and saying, hey, what can I talk to? And so if you actually look on the back of a hard drive, for example, there's another firmware and ROM chip that's on that on the card that's on the back of a hard drive that will then respond to the post order that allows the two to communicate. It kind of starts it up. It jump starts it, if you will. So that's the analyzing and cataloging of other forms of hardware. And then it offers the user a key sequence to enter the configuration screen. Now let's talk about that for a little bit moment. You can see that in figure 1.13, and it's talked about underneath figure 1.13. And this is where you can actually go into the BIOS and configure it. So once the BIOS is encoded onto the ROM chip, it's encoded in a default state. They actually do allow you to go and make changes to it. Now it's done through graphical user interface. Back in the old days, we actually had to get into the motherboard and change little dipstick switches that are on there in order to make modifications to it. But the BIOS will allow you to interact with it up on the screen. And the more technology that's applied, we're starting to get into an actual graphical user interface. Early BIOS was just a bunch, a green screen with a bunch of selections that you can make. But now we're actually being able to use the mouse and so on and so forth. All right, before we talk more about what happens during post, I want to also finalize what we're going to mention what happens in the BIOS when you go modify it. We're going to finalize what happens in post, and that's where the post hands over the control to the boot device, which is usually on the hard drive. So the hard drive has a sector on it, and we'll talk about that when we get to the hard drive section, that is identified as the boot device. And when you lay down an operating system, whether that's Linux, Unix, some form of those types of operating systems, or Windows operating system, it will lay down some specific code that will interact with the firmware and with BIOS to let it know how to start the operating system. So again, let's go back and look at the sequence here. You have a motherboard, a piece of hardware that has another piece of hardware on it that's a chip. We call that the read-only or ROM chip. That has a piece of software we call firmware encoded upon it. And then for motherboards in particular, that firmware has what's called BIOS, or the basic input output system, which initiates the post or the power on self test, which initiates a very small set of sequences that basically allows the motherboard to talk to everything and anything that's out there that's connected to it. All right, so once we fire up the BIOS, you're probably familiar with this because when you boot up your screen, you're given the option of hitting F2 or F12, perhaps F10, but again, let's go by what the book says here, F2 or F12 or delete key. A lot of people don't realize what they have to do to actually get in to modify the BIOS, and also the impact that could have. So first of all, you don't just hold down the F2, F12 or delete key during the boot process. You have to tap it quite frequently. So basically you're issuing an input from the keyboard into the post order that allows you then to enter the BIOS and make modifications to it. So keep that in mind as you're moving forward too. So the BIOS will allow you to run diagnostic routines, or it will allow you to make configuration changes to the very basic functions that go on the computer, even to the point of how fast or the fans that are on top of the heat sinks that are on top of the CPUs are running, or perhaps whether you apply a password to the BIOS, or whether you need to upgrade that firmware to a different level of firmware, perhaps because there might be a security vulnerability out there. These are all things that you can accomplish within the BIOS function. Now, I just spoke a moment ago about updating the BIOS, and that's called flashing the BIOS, and it talks about that on page 20. I want to give you a warning on flashing the BIOS and also applying a password to the BIOS. Now, as a security professional, I'm going to tell you, yes, you need to apply the password to the BIOS if the computer is in a space where it could be compromised, or perhaps if you've got kids within the house, because they could get in and make changes. But let me tell you, if you apply that password, you better know what that password is and have it securely stored someplace, because if you forget it, it's done. You will have to do a lot of things, and there's a couple little tricks, but I'm not going to share those with you today. But there's a couple little tricks where you can override that and cause it to default back, because that's part of firmware. When it loses all power, when it and we'll talk about that with the CMOS and batteries in a moment, or in our next episode. But when it loses all power, or there's dip switches on the motherboard, you can reset it, but it always goes back to the very beginning default in order to get in. So save your password. But then there's this other thing called flashing the BIOS. When you flash the BIOS, you're basically doing an upgrade of the BIOS. But what happens there is the entire BIOS, the entire bit of firmware, is overwritten by whatever, the code. So you would go to, like Dell, if you have a Dell computer, for example, you go to Dell and you would download that firmware, and then you would apply it. It's always going to require a reboot of your computer. It's going to require a very specialized sequence. This is not like updating a regular piece of software. So when you flash your BIOS, it's literally poof, flashing, and it will always reset to default. So if you put a password on, if you put certain settings for your fan, or perhaps to start your keyboard on boot or something along those lines, you will need to go back and reapply those after flashing the BIOS in most cases. So that's a little bit about what we call the very core of the operating source. The software that goes on is technically not an operating system, it's the BIOS. There's a sequence to it. Keep that in mind. And again, hopefully you're learning, hopefully you're following along here. If you have any questions, please MHOUPT at commonsensesecurity.net, and that's one word, Common Sense Security, period, NET. And I'm happy to take your questions. Also, I encourage you to subscribe on YouTube, subscribe on iTunes, and I must ask you, if this is of value to you and it's helpful for you, please give us the 5 stars. Give us a rating on there. And if you don't like it, reach out and tell me what we can do to make it better for you. Remember, I'm just a guy doing something for free. I'm not one of these professional folks. So keep that in mind when you're giving your 5 stars, or you're possibly complaining about what we do here. We're just trying to help. We're just trying to make more IT professionals, just a regular guy trying to help out. So again, MHOUPT at commonsensesecurity.net. Give us those 5 stars. There's the 5. And I hope to see you back, or hope to have you listening back in episode 8 as we come back and talk about CMOS and CMOS batteries.